Cool. Hey, hi everyone. This is Animesh Rastogi. Welcome to the keynote track and thank you so much for joining us. I came all the way from Bangalore. I'm originally from Lucknow. And it's really glad to see an amazing community here at Kerala, Kochi. And I'd like to give a shout out to Humble. Thank you so much for inviting me and thank you so much for creating such an awesome event. And yeah, this I'm assuming everyone here is pretty interested in this community and invested here, and Kubernetes as a topic. And just the panel discussion before obviously also highlighted the importance and the amount of penetration Kubernetes has as a technology in the fact that so many of the large organizations, so much of the global community is so much invested in this technology. So my talk essentially is, in the same spirit. You know, most of the companies, most of the people have used Kubernetes essentially to host their applications, to host their, infrastructure, to basically be a centralized platform, run your business critical application, production, stateless, stateful, different applications. So my talk essentially is going to focus around building for Kubernetes, right? Kubernetes by design is a very extensible, platform. It's designed to be extensible. So in this talk, I'll essentially cover how do you actually leverage that to your advantage and actually build for Kubernetes and solve some really interesting problems that you get to see in production. Right. So a little bit about me. I am a public speaker. I put that at the top because I value that, as a quality in me the most. I'm definitely open source enthusiast. I code in Golang and JavaScript, and I'm a huge go-karting enthusiast. Anybody here likes go-karting? Oh, okay. I guess I'm alone, which is a weird thing, but cool. All right, so let's talk about, so my topic for today is writing a Kubernetes controller in Go, right? Why did I choose this topic? So as I said, right, developing for Kubernetes. Eventually, while you have been using and maintaining this platform for a long time, you'd soon get to realize that, hey, while Kubernetes is awesome on its own, maybe if this had that, it would have been even more amazing for me, right? If it had that, it would have been perfect for my use case. And that's, I think the Kubernetes developers kind of knew about it, so that's why they kept it pretty open, right? The standards are pretty clear. They also created, the APIs in a way that you can use them and actually extend them to kind of suit your exact customized use case. And that's what Kubernetes Controller essentially is. So let's talk about what a Kubernetes Controller is, right? I'm first going to talk about what a standard controller is, and then obviously we'll dive into what a custom controller is. So I'm assuming everybody here knows the basic concepts of Kubernetes. So you have different objects, right? Kubernetes objects like pod, services, deployment. And all of these different objects, when you create, update, delete them, there's a custom code that runs in the Kubernetes API server, like in the controller manager, right? Everybody has seen that API server control plane and data plane diagram, right? So the controller manager has these set of reconcile controllers, which essentially make sure that your current state is actually the same as the state that you applied for. Anybody here actually has taken a look at the code of a controller, deployment controller in the GitHub repo? Has anyone seen the code? Okay, cool. So yeah, it's a pretty long code. It takes quite a bit of things to. It does quite a bit of things under the hood. But yeah, all that magic of applying kubectl apply to actually getting applied is all created and done by a controller, right? That's what a Kubernetes controller is. So I just want to talk about what is the anatomy of a controller, right? What are the different components of a particular Kubernetes controller? So there's something called as event and watchers, right? So each Kubernetes object type, like a deployment or a pod, is required to support a watch, right? It has, so anytime you have done a kubectl apply and then you do a kubectl describe, right? You will see there's something like a resource version that you will see in that Kubernetes YAML file that gets out from the kubectl describe. That resource version is used by any client that you want. Kubectl is one client, or if any client that you write, it can be used by that client to essentially generate a watch against that object, right? So because it has a resource version, for that particular object, you can use the resource version to essentially track its state throughout, its life cycle. And using that resource version, you can essentially create a watch. So any operation that you do in Kubernetes, like add operation, update operation, delete operation, that is an event that gets generated, and any client can essentially, have a watch on those events, right? That's one aspect of it. Second is, what are informers? So imagine you're writing a Kubernetes client, right? That Kubernetes client is supposed to communicate with Kubernetes. It's supposed to communicate with the Kubernetes API server. And now think of it like this. Let's say you have created a deployment object. Because it is, it is basically doing a watch on the Kubernetes server in the sense that it is basically seeing if anything has changed. So what tends to happen is that it will, let's say you have 5 or 10 different controllers running, each of them constantly pinging the API server, hey, anything changed, anything changed, anything changed, anything changed. And that obviously is not desirable in any system, right? You do not want a single component getting a bombardment of requests from something which is absolutely required to it. So that's why there's something called as informers that get created, right? So any client that you create, you use something called as informers. What informers do is basically create a caching layer, local cache in wherever it is running, right? It creates a local cache. And that's where what informers do, it basically they query the resource data once, and then they store it in the cache, and obviously the cache will have its cache expiration period and resync periods. It will store it in local cache, and then only when an event is generated is the informer actually triggers a handler function, right? That's how informers work. So this is another component of a controller. And yeah, event handlers. So now when you create these informers essentially exposes certain event handlers. Everybody obviously understand what event handlers are, right? So these event handlers are 3 types of event handlers: add func, update func, delete func. So you specify, okay, anytime one of these events happen, what to do next. So theoretically, what you will do is anytime anything is added to the cluster, the add function will run, and which will do the reconciliation needed, update. Technically, you won't do it here, but I'll get to it where you will do it. But that's the general point, right? That these event handlers, informers triggers these event handlers anytime one of these event happens, and then you essentially the reconcile logic runs. So this is essentially the actual architecture of a Kubernetes controller, right? This is a low-level architecture. This is what your code essentially does. So let's say you have an API server that side, right? So all of this reflector, this delta FIFO queue, informer, indexer, all of this is part of the informer that I was talking to you about, right? What happens is that these are components of informer which you do not need to worry about, but it's better to know about them, right? So it will list and watch, and it will add object to a queue. And then the actual informer, another process within the informer, will actually pop that object, add the object to the local cache, right? That's how cache is actually filled that I was talking about, right? Informers create a cache. Then anytime an event happens, it will push it to the event handler, that code that I was talking to you about, right? Though you write these resource event handlers, so these functions, the c.add func, c.update func, c.delete funcs, are essentially these resource event handlers. Right now, I said that you do not technically write the logic in these event handlers. What you do is you create a work queue, right? It's a normal queue. What you do is any time any event comes, you push that event into a work queue, and then another process or another Go routine pops that queue and actually processes the item. So you do that to ensure that there is some sort of concurrency to the entire thing. It processes the item, it handles it, and then it either is able to resolve it, right? Either it is able to resolve it, or if it fails for some reason, It will push it back to the queue. You can choose to have it will push it back to the queue directly. You can choose to have a delay in it. Why would you want a delay in pushing it to the queue? The reason you may want to have a delay in the queue is, let's say you're making a external API call. Let's say it's communicating with Slack, for example, right? If anytime this, let's say, controller restarts or anything, right, the controller will essentially get all of the data in the cache, all of the let's say all of the objects in the cache, and they'll bombard the external API, right? So you do not want to do that. You want to have some sort of mechanism in place to include some sort of latency, right? So that's why it will add with a cent of latency here, right? So this was the concept. Now I promise that because this is writing Kubernetes control in Go, we'll have some sort of code walkthrough. Yeah, I think Ram was right. Nobody wants to see this after lunch. But how many of you have worked with Golang and or client Go? 3, 4 people. How many have worked with Golang before? Only those people. OK, cool. This may be painful for the rest of you. All right. One second. I'll just open up VS Code really quickly. Let me zoom in. Can anyone see my screen? Let me close the terminal. All right, cool. OK, so what I have done here, this is in no way an actual controller, because obviously I just wrote this last night. But what this will do is anytime you, let's say, upload or rather add any object in the Kubernetes controller, any deployment in the Kubernetes controller, without specifying or having a container without specifying a resource limit or request, it will automatically send it to a Slack channel. That's all it will do, right? This may not be a very production use case, may not be a production use case, but I have seen similar controllers in the wild. What they do is either they add the resource request or limit, or essentially create that kind of a pull request or something, right? So yeah, that's why I decided, okay, let's create this. So there are a couple of files of note here, right? Main.go, of course. Okay, for non-Go people, how to explain? So main.go and main function is basically what is the main function, as you can imagine, right? If anyone who knows other languages probably understand that. C, C++ guys probably would do better here, right? So what will happen is initially we will, I'll start from here. I'll load any environment variables that I need, which essentially, let's say, Slack credentials that I need to load, right? Slack credentials or the kubeconfig file, anything. Then what I'll do is I'll create a client set. What is a client set? Client set is nothing but it actually is what is used by our client here, which is this code to get to authenticate to the Kube API server. You do not want an authenticated request, right? So what I've done here is I've created a Kubernetes client set. Now that client set is an authenticated client that gets created for the API server. So what will happen here is, as you can see, it will take the kubeconfig file from either this particular path, which is where typically kubeconfig files are stored. So what I've done here is to ensure two things, right? Check whether this controller, this code is running inside the cluster or outside the cluster. If it's running inside the cluster, then so basically if it's running outside the cluster, this is what will be used. But if this fails, right? If an error occurs, it will check whether this code is running inside the cluster or not, right? So because it's a Kubernetes controller, it's going to run inside the cluster. So it will authenticate using the service account that you have attached to that cluster, right? The RBAC, using your RBAC policies. So yeah, it will generate the client set here from using this function. Again, these are all part of client Go library. You can see here, right? These are all part of the client Go library. I am for any Python or JavaScript guys, I think there is a client Python and client Node as well. Not sure, I've not worked with them, but yeah. These are all part of client Go library. So there are 2 or 3 libraries that you need to be aware of. Client Go library is one. API machinery is another, right? API machinery has all the object types, defines all the object types like deployment object as Go code, right? As Go structs and like that. So once you've generated the client, what will happen, as you can see here, you create an informer that I was talking about, right? You create a new shared informer factory. And this 10 into time.minute is the resync period, right? So basically, this informer will resync the cache every 10 minutes in our case. You can make it as little or as much as you want. Obviously, I would advise not do very little and very long for obvious reasons because it's a cache. Right? Then I'll create a dep informer from informer.apps.v1.deployments, right? So deployment obviously lie within the apps.v1 API group, right? Then I will create a new controller from this using this client set and deployment informer, and then I'll start the informer. I'll explain what this channel does in a moment, and then I'll start the controller, right? So I started the informer, and then I'll start the controller. So this is the actual controller configuration. This is where the controller's code lies. So if you see here, I've defined this controller as a struct. For C people, obviously, you'll be understanding what a struct is. Struct is a custom type, right, that you create. So I've created a custom controller type with queue, client set, and dep informers as its fields, right? Oh, very good thing about VS Code as well is the IntelliSense, especially for writing controller, is absolutely amazing, right? It gives you all the details. It also, once you have installed requisite packages, it gives you very great IntelliSense. So yeah, you create a work queue that I talked about, right? That work queue where you push objects once the event handler catches them, client set, and the deployment informer, right? All of these types are also mentioned. Go is a statically typed language as well, right? This new controller creates a new controller, as you can see, right? Again, for Python folks who probably not understand what this ampersand means, this is pointer, right? It basically creates a reference, a pointer to the controller object, and stores it in C. And then what I do is I basically register an add func here. So I've only registered an add func here. The reason being that the use case, again, from a demo perspective, in the use case was anytime a deployment is added, if it does not have request resource, you send it to Slack, right? That's why I just registered an add func here. But if you have a use case to update and delete as well, you can definitely add them. It's the same thing that happens, right? Now this c.addfunc, if you see here, all it is doing, right? It is basically printing adding to the queue, and then actually adds to the queue object that we created, right? It has added it. Now the entire process can begin. Now the actual reconcile loop will start. Up until now, we're catching the request and actually adding it to the queue. Now the reconcile loop will start, which is where essentially you'll write your business logic. Right. OK. Coming to this, right, in the main.go, we did a c.run ch. What is this run function, OK? This run function essentially actually starts the controller. So what it will do is it will first check whether the informer has actually populated the cache or not. If it hasn't populated the cache, then the controller will not run. That's something you have to check. Otherwise, if let's say you by mistake wrote the controller code wrongly, or informer code wrongly, or the informer for some reason is not working, it will essentially print that. And then what it will do is it will this Go keyword. So Go has something called as Go routines. Go routines are essentially concurrent processes that you can create, and it is essentially concurrent, not parallel, concurrent. So what this will do essentially is this wait.until will run this function every this second till a message comes through this channel. Okay, so this is a stop channel. If you see the wait.until's definition, right? Func, period, time.duration, stop channel. So essentially, if you want to gracefully terminate this controller, for example, how do you do that? Anytime a SIGINT or SIG term is received to the process, what you do is you send a message through that channel, and as soon as the message comes to the channel, this wait.until will terminate, and then the controller will basically gracefully terminate. That's why the ch function is there. Right now, as I said, the c.run worker will every second c.run worker will work, right? As its own Go routine. And if you see, this c.run worker is going to run an infinite loop to process the item. This process item function is going to pop the queue, right? C.q.get, it will pop the queue, and it will defer for getting it. So defer essentially means that once this entire function is completed, then this line will run, right? So once it is popped and it is, the entire processing of it is finished, then it will actually forget the item from the queue. It will remove the item from the queue, right? Then what I'll do is, because it's a cache, right, so key value pair, I will get the key value out from this item object. And then what I'll do is I'll handle it to the sync handler function to actually do the reconcile. So obviously, the reconcile logic is written across multiple functions. OK, now from that key, we'll get the namespace and the name of the object, right, which is added right now as an event, right, which has been caught by the add function. We'll check if it is a system object or not, right? If it's a system object, then we're not going to process it. We'll return nil. If it is not a system object, then what it will do is it will get the object, right? So let's say, for example, you have applied an object. What you do is, in the code, you have to check whether that object still exists or not. Because you can run a complete loop, but during processing, if the object goes away, let's say by mistake someone applied it, it deletes right there and then. So we'll check that, and if that is not found, we'll basically say the object no longer exists, right? So nothing to worry about. But if it does, then we'll essentially do a Slack publisher. So we'll actually trigger this function, which will send this message to Slack. So if you see here, this will get the deployment from the informer, and it will create a deep copy, and once it gets the deployment from, it gets, now here, actually, up until now, we didn't write any business logic. Now here in the Slack publisher is where our business logic essentially starts to. We have to check whether, if the length of containers is 0, then nil. If it is not, then what we'll have to do is we'll have to check all the containers, whether those containers have resource requests or not. If it does, right, if it does, we'll create this message. We'll have to check this. If you see, we check all the containers here, and we check if those containers have resource requests or not. If it does, then we'll craft a Slack message, and then we'll send it to Slack. Right? If you see here, this is the API call to Slack that happens. So this is how you write a controller. I know it's a very, very overwhelming stuff, might be very overwhelming to you. But if you understand this basic funda, right? 1 second. If you understand this basic funda, it's it would be very intuitive to you, because all the complicated functions and all the names that you just read, right? All of these are very inherent to client Go, right? Client Go exposes these functions, these methods by itself, right? And again, as I said, IntelliSense is pretty nice. So, so this is the way to write controllers from scratch, right? Directly from yourself. But as you can imagine, with all things Kubernetes, with all things open source, what the community has done is there are many frameworks out there now which provides an abstraction to this entire thing, right? So as you saw here, the business logic was probably 30 lines of code, whereas everything else, the boilerplate was about 150, 200 lines of code. So what Kubernetes community and the other members of the community has done is they have created a lot of these frameworks out there to basically create a best practice for you to basically do it in a best practices manner without having to deal with such Kubernetes constructs and the complications of Go and complications of client Go's constructs, right? So there are multiple out there: Kube Builder, Controller Runtime, which is a sub-project of Kube Builder, Operator Framework, Cooper, right? These, if you use them, you can essentially build one by yourself. But the problem is, the reason I chose not to actually use one of these frameworks for this demo here is because I have seen that in the industry, people use these frameworks and build controllers, and they run well, right? But they still do not understand what is going on at the ground level, right? That's a big problem that using frameworks actually poses, because you choose not to understand what are the different complications going on underneath the system, that you choose to essentially. And when anything goes down, right, anything goes wrong, then you're stuck because you do not understand what is going wrong. So that's why I chose not to essentially demo here. But if you want to use something like one of these frameworks, right, the writing time for a controller essentially reduces significantly, right? You do not have to actually do any sort of scaffolding. This does the entire scaffolding for you. Kube Builder actually, creates the entire folder directory structure with different subdirectories. You can name, using the CLI itself, you can name the controller what you want, what it does, which object it uses, which object it keeps a watch, and if you want to create a CRD as well along with the along with the controller, you can use something like as operator framework, because and you can also easily, using Go struct, right? Just writing Golang structs, you can create complete CRDs, will generate everything for you, right? So these are very, very good frameworks, but it's very critical to actually understand what are they doing under the hood, right? That's why I chose not to have them. But if you want to understand how they work, I have a repo in my GitHub that you can check them out. So it has, I've implemented the same logic that I showed here, right? As a normal as a writing from scratch, as well as using Kube Builder. So you can check that out. Yeah, so this was Kubernetes Controllers, and I think I'm done. Anybody has any questions, I'm happy to answer that. So I know it's probably very boring, and I'm pretty sure for people who do not know Golang, it would have been a painful thing to bear through, but yeah, any questions, happy to answer.
If you guys want a mic.
Yeah, it was pretty overwhelming. I'm sorry, yeah. But anyone has any questions, do reach out to me on LinkedIn, and obviously I'm here, I'm around, so do talk to me. Love to talk to you guys. Thank you so much.
That was a wonderful presentation. Thank you so much.